Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now this might surprise some people because they will probably think it's a ratio of 4 to 1. But we can show here that it's a ratio of 3 to 1. There's a formula we use for this, and it is percentage change is equal to the amount that's changed over the original amount, and all of that times 100%. So how much has changed here? Well, we need to do 10,488 take away 10,254, so that would be 234. Divide it by the original, so the original was 10,488 because it's decreased from that amount, and then times by 100%. And so that's going to be 2.23%. To answer this question, we need to cut this shape into two shapes. So we're going to draw a line across here, and we're going to cut it into a rectangle and a triangle. Now we need to first of all label the parts of the triangle. So the length or the width of the triangle, the base, will be the same as the base at the bottom, so that will be 20 centimeters. And we need to find the height, which is this length here, which is 90 degrees to the base. And to find that, what we can look at is the fact that the total height of the whole thing is 13, and the height of the bit we don't want is 11. So what's left over? Well, 2 centimeters will be left over, so the height will be 2 centimeters of the triangle. So let's work out the area of the triangle first. Which is going to be half times base times height. Half times the base, which is 20, times the height, which is 2, will just give us 20. Now let's work out the area of the rectangle. And that's just going to be the width times the length. Width is 20. The length is 11, so that would be 220. Then to work out the total area of the whole thing, we're just going to add those together. So 220 plus 20, which is 240. The units are all in centimeters, and so the area units will be centimeters squared. To find the surface area of the cuboid, I'm just going to label the faces and do them individually. So we've got A, which is 24 by 13. So we're going to do 24 times 13, which is 312. Next we're going to do B, which is this one at the top, and it's 24 across and 8 is the length. So 24 times 8, which is 192. And finally C on this side here, which is going to be 13 times 8, which is 104. Now notice that the faces all have the exact same face on the opposite side. So this one at the back is also A, this one at the side is also C, and the one at the bottom is also B. So what I'm going to do is add up all the areas of the squares and double it. So to work out the surface area, we're going to do 2 times and then 312 plus 192 plus 104, and that will give me 1,216 centimeters cubed squared, because it's an area. So when simplifying ratio, it's very similar to simplifying fractions, but instead of the same thing having to do the same thing to the top and bottom, you have to do the same thing to the left and right. So I'm going to start here by dividing both sides by 100. So I notice they both have 2 zeros at the end. So that'll give me 10 here and 34 here. Now, these are both even numbers, so a nice easy next one to do is dividing by 2. And we get, was it 17? And 5 and 17, well, they're both prime numbers, and so there's nothing we can cancel them by, so it's going to be our answer, 5 to 17. So the first thing we're going to do is work out the area of the trapezium. And the formula for that is half brackets A plus B times H. Now A and B have to be the parallel sides. So here we've got the 2 parallel sides here. Just pick a different colour. Here and here. So that is A and B. And then the H is the perpendicular distance between them. So perpendicular means it hits it at right angles, so that's what we've got here. So the area would be half times A, which is 28, plus B, which is 14, times the height, which is 14. And so that would be 294. Next we'll do the circle. Now it doesn't look like we've got anything for the circle, but actually the height here is actually the height of the circle as well. So the height of the circle is the same as the diameter. So the diameter of the circle is 14, therefore the radius would be half of that, which is 7, and the area of the circle is pi times the radius squared. So it would be pi times 7 squared, which will be 153.938 blah blah blah. Now I'll keep that in my calculator, because next thing we'll do is the shaded area part, and it says we want to work out the area of the shaded region. So the area will be the total area, which will be the trapezium, take away the area that we don't want, which is this bit here, which will be the circle. So the trapezium's 294, the circle's 153.93 blah blah blah, and when you do that you get 140.061 blah blah blah. It says it wants it to 2 decimal places, so it would be 140.06. To work out the area of this prism, we need to first of all work out the area of the cross section, which is this part here, so this triangle here. So to do that, I'm going to do half times base times height. So it's going to be half times the base, which is 22, times the height, which is 14. That gives us 154. So the volume is the area of the cross section times the length. So the area of the cross section we've just found out is 154, and the length is basically how 3D the shape is. So that's going to be 15. So the answer is 2,310 centimeters cubed. So we're given 21 to 4 is the ratio. We're just going to have our lines in, because what we need to do is make the left hand side be 1. Okay. And to do that, for 21 I need to divide it by itself, divide it by 21, and we're going to do the same to the right hand side. So 21 divided by 21 is 1, Perfect, that's what we wanted. 4 divided by 21 is 0.190 blah blah blah. It says it wants it to 2 decimal places, so it's going to be 1 to 0.19. There is quite an easy way of doing this question, but I'm going to show you the long way and then we're going to work out what the quicker way is. So I'm going to pair up the A and the 1, which it suggests in the question. Then I'm going to work out the A and the 2 as a different combination, A3, A4, etc. Then I'm going to look at the B and do the same thing, B1, B2, B3, etc. Then I'm going to work out the C, so all the combinations with C. So how many combinations are there with A? Well, there's going to be 7 because there's 7 numbers. How many with B? Well, there's also going to be 7. And how many with C? Well, there's also going to be 7. So in total, there's going to be 7 plus 7 plus 7, which is 21. And the way I can work that out easily is work out how many combinations there are with spinner 1. Well, there's 3. How many combinations there are with spinner 2? 7. And we just times the 2 together. 3 times 7 is 21. So for this question, what we need to do is factorise 4t plus 6. Now factorise means put it into brackets. So if I try, what I can do is I can actually put a 1 on the outside here. So 1 times 4t plus 6 is 4t plus 6, but the question clearly states that it is higher than 1. So we need to find another number that's higher than 1 to factorise this with. So if we look at 4t and 6, well, they're both in the 2 times table. So I can put a 2 on the outside here. 2 times 2t is 4t, and 2 times 3 is 6. So what we can do is we can just check that out with smiles and rainbows. Put all my times down there to remind me to times it. So 2 times 2t is 4t, 2 times 3 is 6. So that works because that is the same as this in the question. So we know that 2 times 2t plus 3 works. In fact, it's the only one that works with it being an integer. So we therefore know that the known side, because it says it's a known number, is 2. And the other side will be 2t plus 3. And then when you multiply them together, you get the area of 4t plus 6. So our answer, because it says the length is the known number, so that's the length, then we're finding the width, which is this one here. So it's 2t plus 3. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000, so that would be 9,000,000. And so we're just subtracting them like that. And so we'll get 6991000. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometers and I want to convert it into meters, then we know we just times it by 1,000. So 2 kilometers is 2,000 meters. But if I have something in kilometers squared and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually timesing it by not 1,000, but 1,000 squared. So that's another 3 zeros. You can see here that that's 1,000,000. So we times it by 1,000,000. So 13 kilometers squared is going to be the 13, and then it's going to be times by 1,000,000. So 1, 2, 3, 1, 2, 3. So it's going to be 13 million. Now, It says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him or her 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. I'm going to do just a quick multiplication grid. And what I'm going to do is I'm going to put the 2x plus 3 at the top, so 2x and then plus 3, and then 3x minus 11 down the side. Multiply them out, 3 times 2 is 6, so that'd be 6x squared, 3 times 3 is 9, so that'd be 9x. Minus 11 times positive 2 will be minus 22x, and then minus 11 times positive 3 will be minus 33. Get them all together, so we've got 6x squared plus 9x, because that is a positive, minus 22x minus 33, and we can see here that the plus 9x and the minus 22x are like terms, so we can add them together to make minus 13x, and that's our answer. So our answer is 6x squared minus 13x minus 33. So to do a cumulative frequency graph, we've got to first of all add a cumulative frequency column to our table. And cumulative frequency is just a running total. So we always start off with the first value, which is 10. Then we add the next value, so 10 plus 25 is 35. Then we add the next value, so that's going to be 50. Now, the cumulative frequency is the total amount so far. So for that first 10, for the frequency of cumulative frequency of 10, we're looking at everything up until the 20. So we plot it at the 20. So it'd be 20 and then 10. So this one here. Then the next one, the 35, is everything up until 40. So it would be here. And then the next one is everything up until 60. There we are. Now, next we want to join them up. Now you can draw them up with a curve, and in most exams you can actually join them up with straight lines. So something you can do is just join them up with, click the right one, straight lines like that. And on most exams that's absolutely fine. I'm going to join them up with a curve. There we go. Now technically I should really finish this off with a nice straight bit there, because there's just a constant 50 forevermore. So we can't work out length CE directly, but what I'm going to do is I'm going to start off by finding length BC, and I'm going to do that using trigonometry. So we've got the 90 degrees there, so it will be, well, we'll start by labelling it. So BC is the hypotenuse, the opposite here and adjacent here. We're not using the adjacent, so we're going to just do our SOHCAHTOA, and we've crossed out the A, so we cross out these two, so it's going to be sine. So we know that sine 79 equals the opposite, which is 29 over the BC. So I'm going to put my solving lines in, and we need to times both sides by BC first of all. So we end up with BC sine 79 equals 29, and we're just going to divide both sides by sine 79. Just a bit of rearranging. So BC will be 29 over sine 79. And when you do that in the calculator, you get 29.542, blah, blah, blah. Okay, so next thing we need to figure out is angle BCE. So where are we? This angle here. And to work that out, we're just going to take 79 away from 90. So angle BCE is 90, take away 79, and that's going to be 11. So we know this is 11 degrees here. And we have enough information now to work out CE, because we've got this triangle here, and we've got this length here, the BC, and we've got this angle here. So we've got enough information now. So we're going to look for length CE. We're going to first of all label the sides. So we've got the opposite here, the hypotenuse opposite the right angle here, and the adjacent here. So this hypotenuse is now an adjacent. We're not using the opposite at all, but we are looking for the hypotenuse. So let's do our little triangles now, find out which one we're using. So we're not using O, so we get rid of sine and tan, and it's going to be a cos. So it's going to be cos 11 equals the adjacent, which is the BC value we've just worked out, over the hypotenuse, which is CE. Now hopefully you've realised from when we did it with the sine thing here, that actually we can just swap these two things over. So we can have it as CE equals 29.542 blah 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 over cos 11. Okay, then we put that into our calculator and we get the answer of 30.095 blah blah blah, and it wants it to one decimal place, so that will be 30.1. You're expected to be able to draw a sine, cosine and tangent wave, and here we're asked to work out what y equals cos x looks like on a graph. Now cos x starts at 1, goes down to 0, then goes down to minus 1 at 180, then back up to 0 at 270, then back up to 1 at 360. But don't just join it up with straight lines, that will not get you any marks. You've got to make it look like a wave, and this is not the easiest thing to do, but they are very forgiving over how you do this. As long as it goes through the points, and as long as this bottom bit is a U shape and not a V shape, then normally you will get the mark. So although that doesn't look perfect, that would definitely get the marks. So we're going to start off just by copying down the same equation, and we're asked to make B the subject. So we're going to put our solving lines in. So the first thing we need to do is get rid of this 10 here. So we're going to divide both sides by 10. And that will mean we have a fraction here, a over 10. And we've got the square root b over 3. Now we need to get rid of that square root. So what I'm going to do now is square both sides. Now to square a fraction, we square the top of the fraction and we square the bottom of the fraction. 10 squared is 100. And that will equal b over 3. And we want to get rid of this next, so we want to times both sides by 3. To get rid of a divide by 3, we times both sides by 3. Now with a fraction, when you times it by something, you actually just times the numerator, the top, by that. So it's going to be 3a squared over 100 equals b. So b is 3a squared over 100. So we're told that the two cuboids are similar, which means we can have scale factor, and we can work out the linear scale factor straight away to find out what we times the 14 by to get to the 49. We're going to do 49 divided by 14, big one divided by small one, and that gives us 14, does it? No, 3.5. Okay, so we times it by 3.5. So 14 times 3.5 is 49. But that is the linear scale factor. And this question is all about volumes. So we're looking at going from here to the volume of the smaller one. Okay. So whenever we go from the bigger to the smaller, we're going to divide by the scale factor. So we know we've got to find the scale factor and divide by it. But the volume scale factor is going to equal the linear scale factor cubed, because volume scale factor has 3 dimensions. Volume has 3 dimensions, therefore it's going to do the linear scale factor 3 times in a row, times 3.5, times 3.5, times 3.5, or 3.5 cubed. So the volume scale factor, we're just going to cube that 3.5, and we get 42.875. So it'd be 42.875. And so on our calculator, we're going to do 4,201.75 divided by the 42.875, and we get the answer 98. We're going to start by just drawing the line y equals minus 2. So the line y equals minus 2 will be a horizontal line at minus 2, which will be down here. Next, we're going to do the line x equals minus 1, and that will be a vertical line at minus 1. Now, here's a bit of a problem. We've got no equal to underneath it, and whenever we don't have an equal to, we do a dash line. So we're going to do a dash line here. Okay, the last graph is a little bit harder. We've got I'm going to do y equals x minus 3, and it's going to be a perfectly diagonal line, but down to minus 3. So it's going to be this line here, about there, but it's going to be dashed because we don't have an equal to. So it's going to be a dashed line like that. So if they have an equal to underneath, then it will be a solid line. If they don't have an equal to underneath, it will be a dashed line. Okay, now we've got to work out where the region is. So we've drawn the lines, and the lines are either dashed or solid, and so they're perfect, but we've got to work out where the region is. So we can see on the first one that y is greater than or equal to minus 2. So it's going to be above this line. Okay. You can see on the next one that x is greater than minus 1, so it's going to be this side. So we've already narrowed it down to somewhere in this region here. And here we're given that y is greater than x minus 3. So what we do here is we pick a point. So I'm going to pick a coordinate, and I'm going to pick 0, 0. 0, 0 is always my go-to one. Write out the equation, and I'm just going to put a box here, so x minus 3, and fill in the coordinates for 0, 0. So 0, blank, 0 minus 3, 0, blank, 0 take away 3 is minus 3. So what is 0 compared to minus 3? Well, 0 is greater than minus 3. And therefore, this coordinate is on the correct side, because if we look, we've got y is greater than x minus 3 is our region that we're looking for. So we're looking for that, that's good. And so our region will be anywhere in this bit here, anywhere at all. And you're asked normally to mark it with an R. I'm kind of colouring it in just because your R can be anywhere within this region. It can actually be at 0, 0, anywhere within the yellow region would give you the mark. Okay, so first thing I'm going to do is just a quick sketch of this diagram. And so we're told the lengths are 8 and 6, and the angle between the lengths is 64 degrees. And we've kind of got a missing length down here which we need to find. So we need to find that one. Okay, so let's label them. Now we're going to be using the cosine formula. So cosine formula involves angle A. So we're going to label the angle A. And the one opposite, the one we label as A, is going to be little a. And then little b and little c, it doesn't matter. Right? It doesn't matter which way around you do them. So we're going to write down the cosine formula. So it's a squared equals b squared plus c squared minus 2bc cos a, and so that would be x squared equals, and that will be 8 squared plus 6 squared minus 2 times 8 times 6 times cos 64, and that will be x squared equals 57.916 blah blah blah, and we just need to solve this, and we can solve it by just square rooting both sides. So it would be x equals 7.61000 blah blah blah. Okay, we're asked for the perimeter, and so we need to do 8 plus 6 plus that 7.610 blah blah blah. I've still got on my calculator, and that equals 21.610 blah blah blah. It says it wants its 2 decimal places, so it will be 21.61. The first thing to notice is that 125 is 5 cubed, so instead of 1 over 125 it would be 1 over 5 cubed. And we know that when you have a negative power, it actually turns into the reciprocal of that number. So 5 to the power of minus 3 becomes 1 over 5 to the power of 3. So n is going to be this minus 3. A normal sine wave starts at 0, goes up to 1 at 90, down to 0 at 180, down to minus 1 at 270, and then back up to 0 at 360. But here we're given a plus 45 inside the function. Now, a plus 45 actually does the opposite of what you think. You would think that it would move it right 45, but it doesn't. It moves it left 45. So each of these points we're going to move to the left by 45 degrees. So instead of at 91, this is now going to be at 45, and each of these are just going to move left 45 degrees. Now 45 degrees is 2 squares, so it's just 2 squares worth of moving left. And so we get a really horrible start to this because we don't really know where it's going to start. It's going to start somewhere there. And then we've got a nice U shape, and then down to here. These types of graph are not the easiest to do because they're stretched out, but make sure you have a U shape at the bottom there. And then we kind of guess here that it's going to go somewhere there. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.